part we are going to talk about here is called so we have talked about deployments, replica set, pods. Okay. So the next concept is called cron jobs. Okay. So I told you Kubernetes also allows you to schedule a job, right? If you want to execute a particular container on a particular point of time, like let's say every day at 9 o'clock, I want a report to be running. So I can configure this as a container, and in the Kubernetes cluster, I can schedule it to run on a particular thing. You will see a detailed example of how to run a Kubernetes cron job. You will see that. So that is where in your cluster, on the particular namespace, if you see that, if you configure any cron job, you'll be able to see that here. And next concept is called daemon set. So daemon set, I already given a brief. Okay. So daemon set is something whenever you want a container to be running on all the nodes which are connected to the cluster, then you will be defining this as a daemon set. A typical example will be your kubeproxy, right? So kubeproxy is a container. Whenever a new node is added to the cluster, I want the kubeproxy to be running, then only it can enable the network communication. In the same way, I need to have the Calico node because that is my network provider. So I want the Calico container to be running so that it can enable network communication and then connect it, right? So these things I have to run this as a daemon set. Yeah, another typical example for the daemon set will be, we have talked about the EFK cluster, you remember, which will be doing the log monitoring for your all the containers. So I told that it will have three components: Elasticsearch, fluentd, and Kibana. Basically, fluentd will be collecting the logs from the Docker location. That is where libdocker is there, right? There you have to create the logs will be stored. So the fluentd has to run on every node which are connected to the cluster, and it has to go to the where libdocker containers directory, and it need to put it. So I will be writing the fluentd as a daemon set. This is one of the practical example where you will be using the daemon set. Clear, guys, on the daemon set? Any questions?
Yes.
Okay. And the next concept or the next workload, which you normally bring it in Kubernetes, is called jobs. So we talked about cron job. Cron jobs are scheduled jobs, but sometimes you may have to run jobs when you do a deployment, right? For example, imagine you are running a job, you are deploying an application. Before hosting the deployment, you want basically say the database to be warmed up, or I want to load some data into the database, okay, before deploying the application. Those kind of things you can configure it in the jobs. Okay, we'll see a complete example for the jobs when we go in detail. So it's basically whenever you are doing a deployment, you want to do a one-time activity, you can use the jobs to create and perform them. Okay, this is on the jobs. And we talked about pods, replica sets, it's over. Controller we have talked about. Next is called the stateful set. Stateful set is something, imagine you are going to bring up a application where it has to share the state with other. Like for example, a typical example will be, imagine you are going to bring up a database. Okay, in the database, you want to achieve a active passive kind of scenario. Okay, this may not be a right example, but this will be very easy for you to understand. So imagine in that I will be having two containers running for it. One will be running in the active mode and another will be running in the passive mode. Okay, so when containers has to communicate the state between each other, then you can use the stateful set. Okay, so in the database example, what it will do is, like when the primary container goes down, that is my active container goes down, the secondary container will understand that and it will get the information. So this is the advantage of a stateful set concept. Okay, so this is a stateful set. And next is your services. Services is also namespace specific. In services, you have two options. One is called as an ingress, another one is a service. So it is the same differentiator I explained when we are bringing up things, right? There we talked about layer 4 and layer 7 load balancing. Okay, so ingress, I told it's a layer 7 load balancing. So it will be able to parse the incoming request. Based on the data in the incoming request, it is going to route the traffic. That's called ingress. And next is your layer 4 load balancing. So without even considering the data inside it, it is just going to forward the request to the target container. Okay, either it can be external service or an internal service. You will be able to see both of them in the services area. That's what I'm seeing here. So if you see that ingress, there is no services running on my cluster. And in the services, you can see for the Kubernetes, I have an internal service. For Calico, etcd, DNS, all those things, I have internal services. I'll be able to access them. Okay, so this is where the type is called as a cluster IP. Okay, so these are all the various services we can talk about. Okay. And the next area is called config maps. So configs and storages. Okay, we'll talk about this one by one. So the first thing is when you are deploying an application, you may need to have a system where your sensitive informations are encrypted and stored, right? Like for example, you are using a database username and password. You cannot keep the database username and password as a clear text file in your Git repo, right? You need to store it in an area where it is stored in an encrypted fashion, or at least only the Kubernetes admins will be able to see that. So those kind of things you will be able to define in secrets. So secrets is the area where Kubernetes allows you to store and retrieve sensitive information. So it can be your database password, or if you want to store your key files to access a server. So those kind of sensitive informations, you can store it in the secrets. Okay, and the next concept is called config map. Okay, so in the 12-factor app development principle, we have talked about environment variables. Don't store your configurations in the config file. You need to store it in an environment variable, right? But in the real time, an application may have a like 20-line or 30-line environment variable file. Okay, is there a way Kubernetes allow me to store the complete application configuration file in the environment? That is where the config map comes into picture. We'll see a detailed lab. So you can create a config map. Inside that you can have multiple values, and that complete config map can be imported into the container when the container is running. That concept is called config map. So for every concept, we are going to see a detailed example how it is being used. Okay, and the next concept is called persistent volume claim and then storage class. So I told you my Kubernetes cluster should be able to communicate to my AWS that it can provision a volume, and that volume can be attached to the container, right? So basically in Kubernetes, I will have something called as a storage class. So this cluster is having a storage class saying that GP2, this is a pre-configured storage class. It can communicate to my AWS, okay, and it can provision. So that is what the storage class is. This is where, this is the actual driver which allows the Kubernetes to communicate to the storage provider. And from the storage provider, a persistent volume will be created, okay, and that volume will be claimed by the container using persistent volume claim. So this is the life cycle of a storage when attaching a volume to a container. First, using the storage class, the volume will be provisioned and attached to the cluster as a persistent volume. Then the persistent volume will be claimed on the container using PVC. So this is the use of a storage class and persistent volume claim.